Oh, my favorite chemical reaction. I think it has to be the chemistry of the cytochrome P450s. Here's a catalytic machine that can insert oxygen into an unactivated CH bond at room temperature and pressure. To me, that's a tremendous chemical reaction, but it's even more impressive when you think about the molecule that does that.
This is a nice question. Maybe, I don't have like my favorite chemical reaction. I don't know, maybe because I'm not like an organic chemist or in inorganic chemistry. I'm just play with DNA. This is something strange for a chemist because now, even if there is a lot of interdisciplinary approaches, it's strange to listen like a chemist that work with DNA. So we generally work with like soft interaction. We don't create covalent bonding. So it's I don't really have a chemical reaction in the most I can say like I don't know how to say like if you think about like a reaction, they are different. From the one that we can get with the DNA. We don't have transformation of matter with DNA when we use DNA. So I'm really interested in some mechanism of reaction that to me are, and also some general concept about like the equilibrium. The concept of the equilibrium in chemistry to me is very fascinating because, if you think about an equilibrium in chemistry, you think that like you see your molecules and they seem to be like soft, so they are like they don't move, they are there, but it is not true because each equilibrium is dynamic. So basically, the matter move from one direction to the other direction of the reaction, and this is very, to me, it's stimulating also the fantasy. This concept. I don't really have a specific reaction that I love special.
Okay. It's not directly a reaction, it's more a process. I work with peptides, so biomolecules, and they can aggregate. So it's a self-sampling process, which we also see in macromolecular chemistry, supermolecular chemistry, that you can have molecules that they self-assemble via intermolecular forces and form new three-dimensional structures. And in the case of peptide aggregation, they are both functional, so we can create new biomaterials with them, but they are also associated with several aging-related diseases like Alzheimer's disease, and in this context we of course need to find ways to prevent it, to cure a disease.